Good morning everyone and welcome to today's practical section. Now quickly, without wasting our time, we'll be running to experiment the two aspects, the redox titration experiment and salt analysis. We'll be practicing the salt analysis on Biuret test. Biuret test, that's test for protein that gives the purple lilac reaction, and then we'll also be looking at precipitation test. Now our redox titration today is between iron oxide, potassium permanganate solution. Please follow me closely as we go. We're loading the Biuret, which is the titrant in this case. This is potassium permanganate solution as the titrant. Then with 0. Yes. You drain until it reaches the 0 mark meniscus. Then you pipette. This is going to be our conical flask, please don't mind. This is not a proper laboratory, it's just a mini laboratory. This is iron 2. Now you learn to pipette where there is no pipetter. You disperse in what is representing our, then you dip the last drop, just dip, you don't have to shake or force it. So we are going to acidify our iron. This is dilute H2SO4. Because redox titration is usually in an acidified medium of about 10 mils or thereabouts. Yes. So having done that, we are set for our titration proper, so we could see what we are doing. Now I'm going to raise this up a bit so we could see the reaction that goes on. This is, say, green or pale yellow, and then the permanganate is purple. So you move closer to see. You see what happens? If you are seeing what is happening, I believe you can see what is happening in the flask. As the purple color, the permanganate enters, it decolorizes. That is oxidation. It is oxidizing. Now the end point will be when this is turned brick red. That is, the oxidation reduction process is complete. Then we read. As I do this, you shake. Yes, it's getting to the end point now. I add slowly. I'm going to stop when it stops decolorizing or disappearing. We are almost there. Yes, almost there. The brick red is surfacing now. And then finally, I think we have gotten our brick red coloration. Now, my title value says, my title value is 30.2. 30.2. So now we'll be running the Biuret test, that is test for protein, and then we'll also be doing the precipitation test, and then we'll see the color changes and what they mean or translate to. Now first and foremost, you rinse your test tube to avoid any contamination. You rinse. Now the first test we are running is the Biuret test, and that's a protein solution. So we pick a few drops of our protein solution. At the end of this practical, we are expected to get a purple lilac color change to indicate that protein is actually present in this sample. So, having done that, we had a few drops of sodium hydroxide solution. So this we have few drops of sodium hydroxide solution. Sodium hydroxide has been added. Add a few more, yes. Then having added that, the next solution we are adding is the copper sulfate solution. The copper sulfate solution, I believe you are seeing what's going on in the test tube. Copper sulfate solution has been added. Let's wait for the total reaction and see what happens. So you can mix the solution with your pipette, your rubber pipette. So the purple lilac solution is coming out. I believe you can see that properly. You can also see the color changing gradually. That's indicating protein is present in the sample. Protein present in the sample. So this is lilac. So let's leave it for a while to completely or fully react. Then we check again to see if it has turned fully purple. Now while we wait on that, yes, the purple, can you see? It's turned purple. That is the protein test, showing that protein is present in the sample. Now, the precipitation test, that goes with, let's use a test tube. Like I said, you always rinse the test tube. Rinse your test tube properly to avoid any form of contamination. Then you add a few drops of copper sulfate, the blue solution, copper sulfate. And to the blue solution, we add few drops of sodium hydroxide. Sodium hydroxide. Can you see that blue gelatinous precipitate? Yes, that blue gelatinous precipitate indicates copper ion. Copper ion. But now we are adding few drops of silver nitrate. The silver nitrate. Silver nitrate, which gives us the white precipitate, as you can see, white precipitate. Now, this confirmation test that SO4 ion is. So the blue gelatinous precipitate indicates copper ion in the first one. Now we are running for sulfate ion, confirmatory test of sulfate ion. We go by the same procedure. That's the blue solution, so to the blue solution we'll be adding silver nitrate, Can you see that reaction? White precipitate. Can you see the white precipitation? Yes, the white precipitation shows that SO4 ion, the sulfate ion, is present. That is the white precipitate. You see our protein test has completely turned the purple, while standing for a while to complete the reaction. The purple lilac color is obvious now. So this color, purple, is called the Biuret test for protein. Note that. So now the last one we are seeing is the oxidation reduction test. We've done that by titrating earlier, but let's just see how it also runs here. So we're going to be having our acidified iron 2 iron sulfate. This is iron sulfate. Iron sulfate solution. Then we acidify by a few drops of dilute H2SO4. A few drops of dilute H2SO4. Then we add our oxidizing agent. Here is the reducing agent. Metal are usually the reducing agent, while the non-metal are usually oxidizing agents. So the potassium permanganate is the oxidizing agent. It's the one that is going to be oxidizing now, while this is the reducing agent. So as we drop in, the purple color disappears. Yes, that means permanganate is being reduced, while iron is being oxidized. So the oxidation will be completed, oxidation of iron 2 to iron 3 will be complete when this color changes to brick red. You see the miracle as it disappears, just like we had it during the titration. Yes. You add a few more. Yes, properly mixed. There is still some element of iron 2 that has not been completely, oxidized. That's not completely oxidized, so we add some more to ensure all the iron has fully oxidized from iron 2 to iron 3. So iron 3 will give us the brown or brick red coloration. So at this point, I think the oxidation reduction is complete. The oxidation reduction process is complete. We have a brick red, but let's fully mix. Yes. Now, by the time you have this color, brick red, it means that all the iron 2 has been oxidized to iron 3. So this is the color of iron 3. And it means that all the manganese ion from the permanganate solution has been reduced. The manganate has been reduced to manganese. So this is the solution you are expected to get, the color change. So this is what we do. This is what we observe in salt analysis for qualitative analysis. Yes, qualitative analysis. Thank you. So it's all about color changes. Color changes. These are the products. Yes, from the purple to the brick red to the white precipitate. Thank you for staying to the end. See you in the next class on chemistry with John O.